Hello everyone. So in this video we will look at random variable. So let's start. So what do we know about random variable? So basically random variable is a mapping from the sample space into a real number or vector. Alright, and usually we actually assign random variable because it is more convenient to deal with the summary variable rather than the original probability structure. So for example, if you want to talk about probability of 2 days where we will actually have rain in the week of July 1st to July 7th, then you would not want to be writing probability of 2 days and so on because it's going to be a very long explanation. So therefore it's sometimes better for us to just deal with assigning it to a random variable. All right, and usually we actually denote it by xw. So anyway, so on random variable here, let's see what we actually have. So random variable, as you can see, usually it can be categorized in two forms, right? One would be discrete and the other would be continuous. All right, so what's the difference between these two? If you remember, discrete usually goes by the number, so basically we can say that this is countable. All right, whereas for continuous, well, speaks for itself, and usually it also goes by things that are not countable or uncountable. All right, and also in this lecture we are also going to look at a few different terms on our RV here, yeah, and later we will look at terms like cumulative distributive function, and we are also going to look at expectation. All right, and expectation is sometimes known as mean as well, and as part of statistics, usually when you have expectation of or means, then you also have things like variance or standard deviation as well. So we're going to look at all these later on. All right, so if we just look at a little bit on random variable here. All right, so if I'm going to give you an example on discrete, because once you have understood discrete, then continuous is basically just the same thing, only that it is in a different form. All right, so for example, if we throw a dice, all right, if we throw a dice, then we're going to have a sample space of 1, 2, 3, 4, 5, and 6. All right, and suppose that in this example we are saying that if we throw a dice and the outcome is 1, 2, or 3, we're going to get a profit of -1 for here, which means we are losing here. And if say example that if we draw a 4 on the dice, then we get 0. And for 5 and 6, if it turns out to be number 5 or number 6, then our profit is 2. So for a discrete random variable, and let's assign this as xw here. So basically how I'm going to represent this thing here is that I'm going to write it as x of 1 will be equivalent to my x of 2, equivalent to my x of 3, equivalent to 1. All right, that's how I represent this. Sorry, this will be -1. All right, so let me just write it nicer here. So it will be equivalent to -1. All right, and similarly my x of 4 then will be 0, and the x of 5 will be equivalent to x of 6 will be equivalent to 2. All right, and just from this example alone I am able to draw a table. All right, if you look at the table, I can just assign this in a table where I put x here, can get -1, 0 or 2, which is my profit earlier, right? For this one, -1, 0 or 2. So this is where I can actually put in the probability of my random variable. So my probability would be then my x equals to small x here. All right, so if you look at it, what's the probability of my x equals to -1? All right, so as you can see earlier, for x of equals to -1, I can draw a dice, and when I get 1, 2 or 3, I actually get -1. So based on the probability itself, it will be 3 out of 6, correct? Because all possible outcomes, there are 6 possible outcomes for me throwing a dice, right? So this will be 3/6, which will then be simplified as 1/2. So this is just the normal probability. Like for example, now here for 0, my px of x, where I will get profit of 0 here, is basically when I draw a dice of number 4, right? And this is the only one that I have, so it's 1/6 possible outcomes, which I have 1/6. All right, similarly for probability of x equals to 2, I have drawn either number 5 or number 6, so that's 2 of them, so it will be 2/6, right? So 2/6 can then be simplified to 1/3. Okay, so now this is a normal table where I have my random variable. I can even get the probability of my random variable. So remember earlier we actually talked about cumulative distribution function. So cumulative distribution function is very much closely related to that. So if I'm just going to write down the notation of my cumulative distribution function, that will be f(x) of x. All right, so if you look at it, right, this is what we call as our CDF, cumulative distribution function, and the notation goes like this. It's actually f of x equals to my px of x smaller than x. So from the term itself, cumulative distribution function, let me just show you how this actually applies in the table. So what I have as of here, this will be then just 1/2. All right, but when I reach 0 here, it basically means that I'm going to add up these two numbers together. So this is actually 3/6, right? 1/2 is actually 3/6, and this is 1/6, and upon addition, I will actually get 4/6, correct? So 4/6 will then be translated into 2/3. And similarly for this part right here, I'm going to get this adding up to this, adding up to this, all right? And you can see that this is 2/3, and where you get this 2/3 earlier is from the sum of these two, yeah? So from this sum here, and you add up this, you're actually going to get 3/3, which then is equivalent to 1. So cumulative distribution function is also a way for you to actually verify to see whether your total probability will actually equate to 1 finally, yeah? Because so that's one of the part that you want to look at. And of course, if you're talking about cumulative distribution function, well, we can actually just have a simple diagram where this is 1, 2, and probably this is 3. For cumulative distribution function, you can see that usually it goes something like this in terms of the graph of how it looks like, where the y-axis actually indicates this f of x here, yeah, and at this part here, it always equals to 1, because that's the biggest number that you can actually get for cumulative distribution function. And so this is actually just an example of how a diagram of CDF happens. And say if I do not, and of course this is for discrete, if I'm going to have one for my continuous, So basically it can look something like this, where this is my A and this is my B, and this is also still my fx. All right, just the same thing, only that as you can see, this is continuous, so you actually have a continuous line here, and this is for discrete. Say if you do not want to represent it this way, we also actually have another term for it. All right, so it actually is called probability mass function. So just imagine if instead of this part here, you're actually going to indicate it as point form like this. All right, like this and like this. So what you're going to get is actually this form here, this form here, and this form here. So see that I'm just actually tracing it vertically from whatever CDF they actually really have. And this is what we know as probability mass function. If we are looking at continuous, we also have that, right? So in this case, this would be A and this would be B. And can you guess it? So it's actually the area under the curve. So this is pretty important because you will be able to see this later on as we go along the course later. And for this part here, we actually call it probability density function. All right. So this is just some representation of how diagram looks like and all that. Okay. Okay. So anyway, so let's move on. So we have looked at CDF earlier, right? And then remember earlier when I actually mentioned to you that we actually also have some few terms that we want to look at. So we have covered the CDF here. So remember expectation. So for expectation, so it's quite much related to this part here. Okay, so what do we know about expectation? Expectation is basically the expected value or mean or expectation of a random variable x is actually denoted as E of x. So just for the sake of consistency, I'm using the same example as we have discussed earlier. So you have looked at the probability, you have looked at the cumulative distribution function, and this E of x here is the notation for expectation, or in other words, we know this as a mean. All right. So expectation is given by this formula over here, where your x is actually a subset of your capital X here, and you're given by x of p of x equals to x. All right, so as you can see, it's actually the x, the sum of your x multiplied by your probability of x. Okay, so if you are just looking at this formula here for expectation or expected value or mean, they call it. And if we refer back to the same example earlier, all right, so do you notice something? We can actually calculate what my EX is based on the table above here. So remember, this is x of x and this is p of x, and we actually have these two components as you can see over here. So in other words, it's the sum of the whole thing here, right? So what I get is, first I'll go with this first, my x of -1. So I have -1 here, and I'll multiply with the p of it. The p of it earlier is what I get as 1/2. All right, and then I sum with the second one, right? Because I have x of 0, so that will be 0, and I multiply with the probability, which is 1/6, and the last one will then be 2 multiplied by 1/3. All right, and after you added everything up, it's going to bring you to 1/6. Okay, so this would be then the expected value. So see that sometimes when the question asks you, gives you a simple example, and they actually ask you for expected value or whatever, so just make sure that as long as you know what each term or variable stands for, and you do know how to come up with it, then that should be easy for you then to solve the question. And usually I like to do it in a table form so that it doesn't get confusing and all that. And of course, in statistic form, when we actually have expected value or mean, you also actually might have heard about variance, right? So variance is also one of it. And what is my variance again? By formula, it actually goes by my e of my x minus the expected value. I'm quite sure you have sort of like seen this before when you try to solve for your statistics last time. But what do we know about variance? Variance is basically a measure of dispersion of distribution of x around your expected value, yeah. And of course this is the formula for it. And after variance, you also might be familiar with standard deviation. All right, standard deviation usually is being represented as this symbol here, which we call sigma, and it's actually just a square root of your variance of x. All right, so as you can see, as long as you actually do know what each term stands for, and see to that we are going to look at this quite a bit later on in the next part of our course, so it should be easy for you to solve the questions and all that. So this is on random variable. So in the next video, we're going to look at probability distribution, where you will learn more about normal distribution, binomial, and Poisson distribution. So that will be in the next video.